Hi everyone, welcome to the Earth Science Regents Review podcast series created by Hommocks Middle School Earth Science Department. Today we're going to be talking about the phase changes of water. Under normal conditions, when you apply heat energy to a substance, the temperature of that substance is going to go up. So essentially you're going to have your three basic phases of solid, liquid, and gas. Well, that happens with water too, but water is actually quite stubborn in regards to heat energy being applied to it. So let me talk to you a little bit about what's going on with water. Water has a very, very, very special concept called latent heat. And basically, latent heat is hidden heat of water. It's a hidden heat of water, meaning that water can only take that heat energy and only do one thing at a time. So when you talk about water, water can only do one thing at a time. It can either change its temperature or change its phase. It cannot do two things at once. So when you talk about phase changes and you see the words latent heat together in relation to water, you're dealing with either a phase change of water or a temperature change of water. You can't do two things at once. So let's talk to you a little bit about some of the energy that's going to be needed in order to change one phase of water to the next. And that's what we call a joule. Now a joule is just going to be a unit of heat that's going to be applied to water in order for it to go from one phase to the next. Now, we're going to go through the four basic phase changes of water, and you're going to see that certain phase changes need a certain amount of heat energy, and the big thing you need to understand is going to be on page 1 in the reference table. So make sure you go see my podcast on page 1 in the reference table describing that little section. So melting is basically solid to liquid. In this case, you're going to have an energy gain here. Latent heat is going to be gained, it's going to be taken in the form of 334 joules per gram. So again, a joule is going to be a unit of heat energy. So for every gram of solid ice you want to change to liquid water, you need to apply 334 joules for every gram of solid ice to change it to liquid water. The next phase change is going to be freezing. This is going to be liquid to solid. So basically you're going to go into the solid phase here. This is a latent heat loss. Energy is going to be given off here, and at a rate of 334 joules per gram. So energy now is going to be given off. Evaporation or vaporization, there's going to be a liquid to gas. Energy is going to be gained here in a much, much higher quantity here, 2,260 joules per gram. Anytime you deal with a gaseous phase, you need a tremendous, tremendous increase of heat energy in order to change your phase from liquid to gas or from gas to liquid, which is going to be condensation here. And again, this is going to be a latent heat loss. Energy is going to be given off here at a rate of